Hello. So, we will continue our discussion with cloud computing architecture. So, in the last lecture, we are discussing about this client server, traditional client server paradigm, and what this cloud is offering from the service orientation point of view. We will continue that discussion with the things. So, what we have in case of a client server model, we have a server and we have several clients which are connecting to this server, right. So, we have several clients which are connecting to this particular server. So, this server and client logically or physically can be on the same machine can be client server, different machine can be one client one server, a client can access server for some other things, etc. So, what we do, we have for every server things we have a client, like if I have a FTP client server. So, what we have FTPD daemon in a particular Linux flavor, and there is a FTP client. So, FTP client look for a FTP server. So, in this case what to try to realize, a server, basically the server process waits on a particular port, right. So, what it does, like say if I have FTP or telnet, similarly telnet D, if the telnet daemon server, then telnet, or very popular thing HTTPD, then I have HTTP server. So, all these things are have a particular port. That means, in the server machine, say for say HTTP. So, a particular in the server thing. So, in the port 80, that logical port 80, the HTTPD daemon is listening. So, from somewhere from a client or HTTP client, that is any of the browser, it basically sends a request to the things. If the server is free, it connects to the things and the connection is established, right. So, server does a always listening to a particular port, is any client is there, whenever the client needs a service, it basically hook into that port and it goes on things. And we have seen that two type of that can be a concurrent server which gives services concurrently, or there can be a iterative server one after another. But all these things I require a one component of this whole process, like for HTTP, HTTPD and HTTP etc., to talk to each other. So, somewhat it is more strongly bound, but nevertheless it serves many of our purposes and it is serving and will be serving, and it de facto standard in any type of sort of application where data and application communicates with each other. Now, client server architecture consists of one or more load balancing server sent by the things. Client and servers exchange messages by request response. Client is often maybe a thin or a machine with low computational capacity, not necessarily, usually. Server can be load balanced cluster or a standalone machine, etc. Like if you think about our HTTP server, usually the server is much stronger and fatter systems, whereas your clients runs on anything from your mobile device to laptops to iPad for some any type of devices which can be there, but nevertheless it can be some higher end devices also. So, it basically tries to emulate a three type of architecture. One is a presentation layer at the top level, then logical layer and the data layer at the bottom level. So, this try to realize a 3-tier architecture, and if we, and this is a very popular things which we are used to, and if we try to look at that little bit comparison with the things, what is the thing, or what is the need of cloud computing and where it is different. So, in case of a client server, simple service models, server service clients request. In case of a cloud, variety of complex service models like IaaS, PaaS, SaaS can be provided. So, it is so every service in case of a client server, I should have a server program where the client connect, where in case of a cloud we have different type of XaaS type of service model. So, the way of looking at the service model is different, may or may not be load balanced in case of a client server, whereas usually this cloud are load balanced, that is one of the major aspects what we want to do. scalable to some extent in a cluster environment. So, if things are running on a cluster, this is scalable, and in case of a cloud, it is theoretically infinite scalable. So, anything can be there. The most important thing is there is no concept of virtualization, right, in case of a client server, and the virtualization is our main concept or the core concept in cloud computing. So, these are some of the things, and what we try to show or propose that this cloud computing is able to do much more justification or much more better utilization of the whole resources and able to cater a large number of stakeholders. The picture is not pretty clear, but so just divide the things. One is that at the bottom is the infrastructure of the operational systems, like you see that compute, network, storage, facilities. Middleware is the different type of services, right. So, I have infrastructure things. So, we want to have little bit broader view of this cloud computing, cloud services. So, these are our core bare metal. So, next layer is realization of the services, right. I have IaaS, PaaS or SaaS type of services. These services we used to have some business processes to run. So, it is not the service, not only the services, I want something business, my business process need to be realized. So, I use these services to run different business processes. So, this is business processes, and I can have business process as a service to the thing. There is a presentation layer where we can have directly some interfaces with the users, or I can have some APIs which allows me to connect to this different service model. Like we are used to different type of APIs for different service providers, is that I use that APIs to connect to the thing. So, I expose myself as a service provider giving these APIs, or I can have customized user end some applications, or what we say some particular interfaces to connect to the things. Now, whole thing should have a integration platform, right. It is integration, not that very strongly integration platform, that is integration of the hardware etc., requires some sort of a particular architectural point of view. Where I want to have a service integration, then I should have a orchestration engine, some sort of a execution tree type of thing, right, service application service execution tree. So, integration, then whenever I will do that, then we require that what is the quality of service in doing all those things, whether I can operate at the appropriate level of service what we want to confer. There is a decimation of informations or type of things, right, what services are provided, how to hook into the things, that is information type of things. And finally, I should have a overall governance. This governance may be management of the infrastructure or the management of the whole system. The governance also have legal issues and policies implemented, so that the legally very valid as per the federal laws and regulations. So, this makes the governance, and we basically realize those things with having different services. I am not repeating this, because we have seen this in other form in several sites. So, finally, we are using this realizing this different service model. So, we will just see a little bit again relook into this service model little bit in a little more detail. SaaS, PaaS and IaaS, like one may be the sometimes we used to have a traditional analogy with our transportation, like roads are the infrastructure, carts and trucks are the platforms which carries the thing, and goods and people might be considered as the software or information in a technical terms or technical paradigm. So, as if I have this infrastructure, over that I have different platform, and these different applications are running over the things, if we look at the point of our cloud computing paradigm. So, software as a service is this definition, I am not repeating this, it is a software that is deployed over the internet, uses a pay as you go model, and there is and you can basically search and leverage that service for the things. Characteristics: web access to commercial software, that is one of the typical feature. Software is managed from some sort of a logically centralized location. So, it may be distributed and deployment distributed fashion, but the management is logically some sort of a centralized location, right. I say that I give a some sort of a software as a service for computational support for different simulation, right. So, or mathematical simulation etcetera. So, this overall simulation platform may be running on heterogeneous different platforms, right, or maybe on a distributed systems, but the overall management is logically centralized type of things. Software is delivered in a one to many model. So, it is to one to many, users not required to handle upgrades etcetera, that is one of the features. Application programming interface allow for integration between different pieces of software, or APIs allows us to amalgamate or integrate different softwares to realize a larger thing. Where it is extremely useful or may be useful is the application where there is a significant interplay between organization and outside world, like email, letter campaign software, like. So, there is a lot of interface between the things. Application that have a need for web and mobile access, right. Software that is only to be used for a short term needs. I don't require something always, but I only want to use for a short term need, like I want to run a particular examination or particular written test for interview, and I want to run that thing for a particular thing. It is for not that day to day I am running the things. So, neither I want to deploy those everything on the thing. So, I have a somewhere I can get the services, and I realize the services over the say desktop on a particular lab and execute that examination and then forget that thing for the time being. So, software where demand spikes significantly, like tax, billing etcetera, right. So, the demands are have spikes, right, like usually the tax submission or the tax fillings has a particular time window during the years, and that time the demands increases, otherwise slows down, and that is important. Then these are some of the popular or well used things, that Salesforce, CRM and type of things. Application where SAS may not be the best option, right, the other side of the story. Application where extremely fast processing or real time data is used, right. So, where because what we have seen that the cloud computing may not be or cannot be considered as a high performance real time of type of operations. There can be delay, and at times it may be slow down and type of things. So, applications where extremely fast operations for real time data is needed may not be the things, maybe say for example, disasters management etcetera. So, I cannot leverage something and which takes times and type of things. So, I have to have something which is more concrete. Even I am provisioning, it should be dedicated with a particular QoS maintenance. Application where legislation and other regulation does not permit data being hosted externally, like I can say that if my institutional work or in our institute say that organization can say that all institute for a organization, the organization related communication over the mail should be on the organization mail server or using the organizational email ID. It cannot be on a public type of things. So, because that is the legal provision in the data where I do not like to see. Application where an existing or on premise solution fulfills all the organization needs. It may be there that already you have a legacy applications which is fulfilling your organization need, it may not be want to shift. Similarly, for platform as a service, it brings benefits of SaaS bought over the application, but over a software development platform. So, it provides the things. It is being software developed over a web, it is a platform for creation of the software delivery of the things. So, it gives a platform to develop your own system etcetera. So, there are several characteristics like services to develop, deploy, host, maintain in the same integrated development environment, web based user interface to create tools to create, modify, test, deploy different user interface and other things, multi-tenant architecture where multiple concurrent user utilize the same deployment application, or built-in scalability is there, integration with web services, support for development team collaboration, that is important. Then I have a development team which is spread over several regions, maybe several countries, and want to have a common development platform and want to work on it, that it gives a good solution. and tools to handle billing, subscription management, etc., are other aspects of the things, that how do I manage the whole show. Where is extremely useful or very useful is that especially useful in the situation where multiple developers will be working on development projects that we are discussing, where other external parties need to interact with the development processes, etc. So, I have a development teams which is the core in our organizational office. I have development team at the customer premises which interact with the customer day to day basis, and there may be other subsequent development team in the head office and type of things. So, when we want to coordinate between these two, this platform as a service may be a ideal base for looking at it. PaaS is useful where developers wish to automate testing and deployment. So, if you want to automate, then these are the things where you put something which is being checked. Popularity for agile software development, a group of software development methodology based on iterative and incremental development. Also, where in these cases also what we find that PaaS will be extremely useful. So, some of the popular PaaS and type of things are, one is Azure and Google App Engine. There are other several stuff where people are using for developing their applications and making it is web enabled and available over webs. Scenarios where PaaS may not be idle. So, it is may not be the good choice, where application needs to be highly portable in terms of where it is hosted. So, if it is high portability is required, then it may not be a good choice, where proprietary language or approaches would impact on the development process. So, there may be proprietary languages, approaches, especially in mission critical stuff, like in case of a defense, in case of some of the cases of financial sector, you may not want that organization may not want to do in this all open system. Open, I do not say that it is a open source only, but it is not on a public systems rather than on proprietary things, and there can be some proprietary approaches of looking at the problems. So, there this type of things may not be useful, where proprietary language would hinder later moves to another provider, concern of rest, etc., vendor locking. So, there is another issue of vendor locking come into the thing. So, it is a vendor locking, then also we have a problem here, where application performance require customize of underlying hardware and software. So, my objective is to have a application performing at its best, then I need to customize that the underlying hardware and software. That means, I want to have a customized stack, right. I do not have a generic stack of the thing, but I have a customized stack, then this type of things may not be PaaS may not be a good choice. And finally, that IaaS, so it provides a infrastructure in terms of servers, storage, network, operating system on a on demand basis, right. So, in rather than purchasing or maintaining, we can have a virtualization of those things, like, or I can have a VM virtual machines and virtual storage and type of things. So, that is the IaaS, extremely popular and used. Characteristics are well known, that resources are distributed as services, allows dynamic scaling, has variable codes like this. I can have again pay as you use utility pricing model, includes multiple users on a single piece of hardware. So, I can have number of users working on a same hardware stack or realizing different virtual machine on the same hardware stack, where it makes lot of sense, where demand is very volatile, right. I have sometimes a machine of a particular memory requirement, sometimes some other requirements. So, demands are very, that means, there are spikes are there, or new organizations without the capability of investment in several organizations or several projects, or what we see that we immediately purchasing something on the hardware is may not be feasible, or sometimes what we want to do some of the POCs, proof of concepts, that time also these are not purchasing takes a lot of time. So, or I can have a kickstart of the whole process. So, there the IaaS is helpful, where there is a pressure on organization to limit capital expenditure, one of the things for specific line of business, trial or temporary infrastructural needs. So, that means, what we say that proof of concept, etc. Where some of the cases where it may not be the best option, where the there may be regulatory compulsion or legal issues to make things, you cannot make the some your data, your computing on the other premises, or you cannot outsource the data storage or computing. There can be some of the legal issues or regulatory bindings on the things, or where the highest level of performance are required, right, on premise or dedicated sources are required. Like I say, some of the mission critical operations where you require some of the highest level of performance, where you want to customize the whole thing, right. That in those cases this may not be a good solution, having a generic infrastructure and realize. After all, when you are having these VMs, so you are having multi things, like you have underlining hardware, over that some virtual machine monitor, and then you are realizing different VM. So, what happened, all these stuffs is basically takes some amount of resources and computational time, right. So, when it is a mission critical, where you want highest level of performance, so you may not be looking for this. So, these are some of the popular SaaS provider. We are not going much detail into the things. So, they have different pricing model, like some are pay as you go, some of the provider are free, some are subscription based, that amount of you subscribe for a year and then use it and type of things. These are feature of like PaaS provider. So, I can have we are having different PaaS provider, and they provide different type of things, like some are on the using databases, big table, own databases. So, the different type of characteristics. You can see that there are different type of target to use, some .NET platform, web development, enterprise application, etc. So, it has different type of flavors to offer to the consumer. And there are IaaS provider, major IaaS provider, there are several other IaaS providers also, and they have different type of capacities, like there you can have different type of hardware capacities, there are different type of operating systems, and we have different type of billing mechanisms into the things. So, these are the different type of IaaS providers. And if we as we have discussed already and discussing. So, if we relook at that again typical stack of these components, then what we see that in case of a SaaS, up to the application level, the managed by the service provider, right. So, it is at the application level, it is the responsibility of the cloud service provider to look in, whereas in case of a XaaS, the responsibility is up to this runtime things. So, the data and applications are the users, whereas in case of a infrastructure, up to virtualization and providing VMs is the responsibility of the provider, whereas over that sometimes it will provide the provider will provide the guest OS, or you can allow you to load the guest OS. Actually, basically you can choose your guest OS to be loaded on the virtual machine. So, that and rest of the things is basically a responsibility of the IaaS consumer or the user. So, if we look at another aspects of this cloud is the networking, right. This networking plays a very what we say important role, critical role I should say, in realization of the things, because at the bare metal you are having different hardware resources, right. So, they are connected over the network. Those who have seen these different aspects, I mean different say the rack server or especially this blade server, etc., you will find that there is the backbone network is very high redundant type of things, because all these servers at a extremely high operating speed work with this network. So, network plays a important role in cloud computing. There is another aspect of networking, that whether I can virtualize this network. Like I say, I have a typical network scenario in a for my organizational need, right. So, I want to set up a network for organizing a particular event, and I have a thing like I can say that these are my routers and these are my servers, and so on and so forth. Now, one way of looking at is that I purchase the thing, separate things and connect the thing, right. Other, whether I can virtualize this whole infrastructure itself, right. I have a what I mean to say, as I get a virtual machine, whether I can get a overall a virtual network. So, I realize this network for the time being where the events will be there, it may be some examination, it may be some other decision making something etcetera, and then I give away the network and the things. So, in other words, I have some sort of a soft way of realizing this overall networking. So, that is another aspects of this. So, in cloud computing, network resources can be provisioned dynamically, as we have seen. Some of the networking concepts that can form the cloud core of the cloud computing are virtual local area network, like, or what we popularly say VLAN, VPN and different protocol layers. So, this allows me to have realized this. Example of tools that help in, there are different tools and techniques like OpenSSH, OpenVPN are some of the popular thing. And if you have networking in different cloud models, so if you see that these are our OSI, typical OSI stack, and if we look at that in the IaaS. So, in IaaS up to this data link layer is provided by the provider, rest are the consumer responsibility. On the other hand, in case of a SaaS, the responsibility of the providers goes up to the whole stack, right. So, where in case of a PaaS, this what we have, the provider has a responsibility up to the presentation or sometimes the session layer etcetera. That means, it gives a platform. So, if I want to realize this OSI as a service model, then I have different type of realization when we look as a whole infrastructure, whole as a platform or as a software as a service. So, what we see that networking plays a important role into the things. There is another concept what we say network function virtualization. We will just have a quick introduction. It aims to transform the way the network operator architects networks by evolving standard IT virtualization technology to consolidate mating network equipment types into the industry standard switches etcetera would be located. What it tries to say? It says that it tries to emulate a network over the infrastructure, right, as we are discussing. It involves implementation of the network functions in software that can run on a range of industry standard server hardware, and that can be moved instantiated in and various location of the network as required without need of installation of media requirement. That means, as if I will little bit discuss in our subsequent talk. So, as if I have a infrastructure and I realize several network over the things, like these are the classical approaches, and here I have a infrastructure, then I try to realize different network over this basic infrastructure, or I can have different virtual networks over the same infrastructure. So, if it is possible, then not only this having these different virtual machines, I can have different virtual network for the things, or I can realize a virtual network on the things. So, we will stop here for today's lecture, and we will continue with our discussion in subsequent talks. Thank you.